Uh, let's start. Yesterday we discussed Spark SQL, right? So to write Spark SQL processing logic, what is required, Ravi? We need to create SQL context or Hive context, right? Rameshan, to write Spark SQL processing logic, we require SQL context or Hive context. Next one, it will create data frames or data sets or tables. So storage objects in Spark SQL is data frames or data sets or table, right? So we discussed how to load CSV file and how to load JSON file and how to load XML file. So we discussed all these examples. Today what we are going to do is we will discuss different data types in Spark SQL. Different data types in Spark SQL. Why do we need data types in Spark SQL? First of all, why do we need data types? In Spark SQL, we create a schema of a table or data frame, right? First, we create while loading. If file contains schema, then we will specify. If it is a CSV file, we will specify infer schema. Okay, assume your CSV file doesn't have header. CSV file doesn't have header, and we want to instead of infer schema taking data types automatically. Yes or no? If it is a numeric value, it is taking integer. If it is a string value, it is taking string type. If it is float value, it is taking double type by default. But I don't want a double. I want a float. I don't want integer. I want a byte. I want to assign my own data types because employee number is less than integer range. It is just byte range. So instead of allocating higher data type, because it occupies more memory space, right? So instead of that, I want to allocate byte data type so that it will reduce size. So if you, while creating schema, or if you want to create a schema to your table, then we use data types in Spark SQL. We can create our own schema. We can assign that schema to data. You got the point, right? We can create our own schema and we can assign that schema to table. We can assign that schema to table. So while loading a data frame or data set or table, so while loading data, we can assign the schema so that corresponding types are assigned to particular columns. Okay, you got the point, right? Why we require uh, data types in Spark SQL. So we have different data types: byte, short, int type, long type. These are integer category. Integer category. Float double type is float double. Decimal type is floating point category. String is type is string category. Next, binary is different category. Next one, boolean is different category, and timestamp is different category. Date and timestamp is different category. Okay. So along with this primitive data types, we have complex data types: array type, map type, structure type. We have complex data types. We have complex data type. So these are different data types are available in our Spark SQL. Spark SQL. Okay. Let's see cancer data.csv file. Let's go to our working directory. Where is it? It is under desktop. under quality thought. So here under quality thought we have Spark and Scala. In this batch 3 workspace, here Spark SQL, right? This is our Spark SQL. Okay. So what I'm doing here, let me open Notepad. Let me open Notepad. So this is our Notepad. Okay. So here, yep. Let's go and take data. So we have a data. Let's see where is data here. Batch 3. We have a data, right? Call log data. Let's take call log data. Copy this call log data. Oh, what I'm saying, copy this call log data and place this call log data under workspace, Spark SQL. Place this call log data. Okay. So this is my call log data. Let's open call log data. So here, if you observe this one, this is my call log data. This is my call log data. Let me check. We are using not call log data, cancer data. Let's open cancer data. So we don't have a cancer data here. So let's copy from my other directory. So cancer data, let's copy this one and place this one into our Spark SQL directory. So let's open this cancer data.csv. If you observe here, we do not have any header. We do not have any header. So what I'm doing, I removed header part. Actually, header part is, this is the header part. If you observe here, it contains this header part. So this is the header part. It has 11 columns. It has 11 columns. Okay. So cancer data.csv, I removed header part. So I want to create a schema. So what I'm doing, cancer data.csv. So cancer data.csv, we have 11 columns. 11 columns. 11 columns. I want to create schema to this cancer data.csv. So let me see. Okay. So what I'm doing, I want to create a schema. I have already schema. Instead of writing complete statement, I'm copying that one. Yep. So this is schema. So what I'm doing, so first up to this part I'm copying into one file. So we require up to this part, right? SQLC. So I'm copying this one into one file. So copy this one, importing. First we need to import org.apache.spark._. What is the purpose of this one, Rameshan? Perfect. First one, it is Spark core package. My question is, what is the purpose of importing this package? I know this is Spark core package. Then why we are importing this package? We are writing, we are writing multiple applications, but we don't know why we are using this package. Already we discussed many times why we are using this, why we are importing this package. I'm asking why we are importing this package. Perfect, Ravi. So first one, this Spark context class is presented in this package. Okay. Next, coming to this package, why do we need this package, Hemant? We just discussed answer similar to that one. We can say SQL server. Wow. Oh my God, Hemant. SQL context, not SQL server, Hemant. For SQL context, SQL context class is presented in this package. Okay. So for these two, we need to, I'm saving this one into our desktop and quality thought, Spark and Scala, batch 3, workspace, Spark SQL. Here what I'm doing, SQL import, SQL import, just I'm saying SQL import. Because we are going to write multiple times, so we are going to write Spark SQL programs, right? So instead of adding these statements multiple times, then I'm using this one. Okay. So let's go. Yep. Let's open IDE. Let's open IDE. So we are doing up to this part. Okay. If header is presented, if header is presented, we are following this approach. So CSV file means we cannot expect a header. Yes or no? Sometimes we get header, sometimes we won't expect header. If header is not presented, we want to create schema. Then we can assign that schema to this file. While loading file, we can assign this schema. Okay. So if header is available, what is the approach we are going to follow? If header is not available, what is the approach we are following? Okay. Okay. Let's go. And here, what I'm doing, I'm changing our workspace. Our workspace is different location. It is in C desktop, right? C users under Sandhya Srinivas user under desktop under quality thought, Spark and Scala, batch 3. Here workspace, here Spark SQL, right? Yesterday we created this directory, workspace directory. Yes or no? So we imported these files. Let's click on SBT cell. Instead of typing import statement, we created one file. What is the file name, Hemant? Hemant is not answering anything. Are you there, Hemant? No worries. At least give me any answer, whether it may be wrong or right, so that you will get Hemant. No one, even if you ask some questions in high machine learning in Spark, I cannot answer. I don't know machine learning. So no one knows anything. No one knows all. So you started learning means you have interest. That's why you are learning. So console, type console. My intention is if it is interactive, you will remember the syntaxes. Keep on discussing and going, closing our course. If I ask this kind of questions, you will remember the syntaxes. But real time, finally, after writing these interactive programs, you have to write this Spark application. Finally, convert this Spark application into jar file and submit jar file. Finally, we submit jar file to standalone cluster. We discussed standalone cluster or Yarn cluster or Mesos cluster. In industry, most of the times we work either standalone cluster or Yarn cluster. Most of the times we work with Yarn cluster. Yarn cluster is most popular because already data is in Hadoop. Then if we use same cluster for processing our Spark applications, no need to set up other separate environment to process our data, right? No need to create a separate cluster environment to processing. We can use existed cluster and as well as data is presented in same cluster. So finally, we convert our applications into jar files. Then we run that jar files. So we are going to do all those operations as part of our course. Okay, let's import that one. So colon load import. What is the file name? Uh, SQL import, right? SQL import. SQL import.txt. SQL import.txt. So it is importing SQL, Apache Spark package as well as Spark SQL package and created SQL context. Before that, it is created Spark context and it is created SQL context. Let's type SQLC. You will see reference. So this is the reference. Okay. Next, what I'm doing, I have already uh, cancer data with all columns. Cancer data. Oh, right click on this one. Copy. Cancer data with columns. Cancer data with columns and data, right? What I'm doing, so I want to load that file. Can you tell me how to load that file, Ravi? Can you tell me how to load that file? Val df1 equal to sqlc dot read dot format, and what is the format? CSV, right? CSV dot dot SQL dot read, SQLC, not SQL, SQLC dot read dot, yes, perfect, super, dot option header comma true. So we are saying that file contain header dot, instead of taking default data types, and we are saying in dot option infer schema, because we have a columns, right? So we are saying infer schema, it will take column names instead of taking default column names. So we are saying infer schema means take columns and corresponding data types. Infer schema true. Then continuation, what is dot load? What is the file name we are loading? So we have cancer data in same directory. That's why cancer data done dot csv. Then I'm using, instead of complete path, what I'm using, cancer data 10 dot csv, cancer data 10 dot csv, right? That's it, right, Hemant? Press enter. Yep. Now df1 dot show of 10. I want only 10 records. I got 10 records. Still it is taken default columns. Why it is taken default columns? Did we done any header? Oh, spelling mistake, right? Spelling mistake. Header. Spelling HEA, right? Header. Header 2. Let's execute this one. And once again, df dot show. This time it is consider our column names, right? Now df1 dot print schema. df1 dot print schema. Observe, name id type is integer, but instead of integer, if you want to take a byte, not possible with default option, right? Yes or no? If we create column names with corresponding data types, we can set data types. But if you say infer schema, it will take a default column type, it will read column names, and based on the data presented in that column, it will assign some default data types. Instead of integer, if you want to assign byte or short, it is not possible with the default approach, right? Infer schema. We have to create a schema, and we have to apply that schema to our data frame. Okay, whether it maybe has columns, whether it doesn't have a columns, then we can create our own schema. Let's assume we have a file. This is our file, cancer data. This file doesn't have a headers and doesn't have any data. So we are creating schema. So to create schema, we need our own data types. Yes or no? To create schema, we need our own data type. So if header is not available, header is not available, and if you want, if you want, if you want, if you want, create your own schema. If you want to create your own schema, then we go for this approach. So first we need I said we discussed some SQL data types, right? That types are presented in this package. So without using this package, we cannot create, we cannot we cannot use Spark SQL data types. So remember one point, Remember one point, we have to import this package. Okay. Then I'm creating my own schema. For 11 columns, I'm creating my own schema. Observe here, val schema equal to struct type is a predefined class. By using struct type, we have 11 columns. So we will define definition to each column. So first column is struct field ID and integer type and value is false. Default value, what I am saying, false. So ID integer type. Next colon struct field second column name and what is the type. False means it has values. It has values. If any column allows empty, then we say true. Okay. Next one, struct field age integer type true. Next struct field gender. So like this we have 11 columns definition. 11 columns definition. So we created schema. Schema is created. Then how can we assign this schema? How can we assign this schema to file for creation of, while creating data frame? How can we assign this schema? So we have an option, while loading data, we are using SQL dot read dot format CSV header. We don't have a header. Then I want to assign this schema to that file. Then we use this syntax. Observe this syntax. SQL read dot format CSV dot schema. We are passing our schema name. Dot schema. We are passing our schema name. So what is our file name? It may be same file. It may be our file. What is our file name? Cancer data. Just we have cancer data.csv, right? Yes or no? Use this syntax. That's it. Use this syntax. Then it will assign our schema to this file and creates a data frame. Okay. Then df1 dot print schema. So schema is integer, and stage is integer. In previously, it is taken stage is string type, right? But we are changing stage is integer. Okay. Next one, df1 dot show of 10. So it is printing 10 records. It is printing 10 records. If you want to change instead of okay, we know how to apply schema to column, right? We know how to apply schema. Now let's see DSL. Domain specific, domain specific, domain specific language, domain specific language, DSL, domain specific language. Domain specific language. DSL is DSL is similar to SQL, similar to SQL. DSL is a language of DSL is a language of data frame, data frame, data frame. DSL is a language of data frame. Okay, data frame language. DSL is a DSL is a language of data frame. So it look like same as SQL. So to retrieve data, sorry, to apply SQL statements on data frame, we use DSL language. Okay. See, I want only few columns. Select ID, name, age, gender. Select ID, name, age, gender. Then we go for what? This approach. So data frame 1. So show function retrieving all columns, right? And specified number of records. Yes or no? It is retrieving all the columns, right? But I don't want all the columns. I want only few columns. df1 dot select, and I want what? ID, ID, comma, name, comma, uh, let's see, diagnosis, cancer, cancer disease, staging, treatment, survival, or state. I want state. What is the state of that person? Let's execute this one. Yep, it is executed, but we want to display the results, right? Again, we can use show. So we got ID, name, state, right? So it is looking like SQL statement, right, Ravi? It is looking like SQL statement, right? Ravi, are you there? Yep. Rameshan, it's looking like SQL statement, but a little different, right, Rameshan? Slight different. You are correct, Rameshan. Slight different. But if you want to apply SQL statements, if you want to apply SQL statement, I want to use only SQL statement. I don't want to use DSL statements. Then you can convert data frame into table, Ravi. If you want to apply direct SQL statements, we can convert data frame into table. You can convert, we can convert, we can convert data frame into table. On table, you can apply SQL statements. So before applying SQL statement, first let's learn all our DSL language queries. Get hands on DSL language queries. Okay. If you want to apply queries, we need to convert the data frame to tabular form, table. Okay. Then we can apply SQL statement. Before that, let's learn other DSL statements. See here, and we can apply select query, or another way. So this is one more way to select columns. We use this approach. We use this approach also. Val df2 equal to df1 dot select call id, comma, call name, comma, call age, comma, call gender. So we are getting some error. So this call is a function. So this is function. So to use these functions, we have to import one package. So import org.apache.spark.sql functions. So we need to import this function. We need to import these functions. Otherwise, we'll get error. So let's import these functions. Once again, execute this one. So this time we will not get any error. See, previous syntax is very simple compared to this syntax, right, Ravi? Previous syntax is very simple compared to this syntax. Yes or no? Sometimes we go for this syntax. Sometimes we go for this syntax. That previous syntax doesn't support some cases. In some cases, we go for this syntax. When we go for this syntax means, Ravi, if you want to perform any calculations, expression, we have to write some expression, right? But previous one, we just used column names. Yes or no? We didn't use any expression. So for expressions, they given some other functions, Ravi, Rameshan. For expressions, they given some other approach. We'll see that approach also. Okay. So first we see this approach. So df2.show, we got data. df2.print schema, we got a print schema, right? Only few columns. Okay. Next one, we have other approach. Other approach I am showing here. This is another approach to read data for particular columns. This is another approach. Observe this approach. Val df2 or df3 equal to df1 dot select expression id, comma, expression name, comma, expression age, comma, expression gender. So third approach to read columns. Next df3 dot show, we got data. df3 dot print schema, df3 dot print schema. So we got data. Yes or no? So this is another approach. This approach will help us to calculate values on column. This approach will help us to calculate values on column. Okay. This is another approach. And we have some more approach. Other approach. If you use select star, if you use df1 dot select star, select star means all columns. Select star means all columns. Select star dot show, all columns. So like select star from table name. If it is a SQL statement, we return lengthy code. DSL is very simple, right? Compared to select query, DSL query is very simple. Yes or no, Rameshan? Ravi? So compared to SQL, it is looking very simple. We write a lengthy code, here we are writing simple code. Still, we want to write SQL code. Why we want to write SQL code? We are familiar with childhood onwards. Means when we start IT career, we started writing SQL queries. So we are strong with SQL, or we are familiar with SQL. Then go for convert data frame to table, write SQL queries. So we have a facility. We have a facility. So don't start to implement Spark application. Write your SQL queries that will work on Spark. That's what they given Spark SQL. You are a SQL developer or some other developer, but you know SQL language. Then no worries. No need to stop our implementation. Let's start implementing our Spark SQL programming. You know SQL, right? Write your SQL statement. Spark will take care of everything. For that one, what we have to do? You need to know how to convert data frame to tabular format. That's it. Only one statement extra, it will come. Learn that statement, how to convert the data frame to table. Then apply your SQL statements. It will not stop our development. It means a non-SQL programmer can directly work on Spark SQL. A non-SQL programmer directly works on SQL. So this is the advantage. Okay. And conditions. See conditions. I want select star where gender equal to male. I want only male records and where age greater than 50. Where age greater than 50. I want to data frame. I want to create data frame. I want to create data frame df1 dot uh, select star. I want all columns or df2. Let's take df2. Select star. I want all columns, but gender equal to only male. And age greater than 50. Then df1 df3 dot show. We got all male records, right? Very simple, right? DSL queries. Very simple. Just select dot where condition dot where condition. Like this, you can add any conditions. It's very simple compared to existed SQL language, right? Yes or no? So that's why SQL Spark SQL became very popular. Spark SQL became very popular. It's simple and works parallelly. We are writing simple query only. If you submit same query, you will see miracles. Same query, you will see miracle. Data size may be terabytes, petabytes, exabytes, any size. Simple query showing very good performance because parallel processing. If you apply same query, select query in RDBMS, if data size is huge, you cannot expect when you will get a result. If data size is petabytes to exabytes, zettabytes, huge volumes of data, you cannot expect your response. But if you apply this simple query, you will see miracles. That is the advantage of power of our Spark. Why people are giving this much importance nowadays for Spark is why lot of openings are for Spark is because of this parallel processing. See, I'm saying one simple scenario. In Hyderabad, recently my friend started looking on Spark and Hadoop. Hadoop, he put resume just last Monday, I think. He put Monday. Monday he got around 60 calls per 60 calls first day. He put Friday evening. He updated Saturday, Sunday. He got Monday 60 calls in Hyderabad. He put only Hyderabad. Lot of openings are there, Ravi. Commission. Lot of openings are there. Only one thing, people learning, people learning lot of people also there started learning, but they doesn't know how to express Spark in interviews. If you show this kind of scenarios, if whatever we are learning, say this approach, we are using this kind of syntaxes, we are using this one, we are using Spark or these functions. Take some scenarios, prepare and explain. If you have a very good on Spark Core, Spark SQL, streaming is optional. They are expecting Spark Core, Spark SQL. And if you have a Hadoop, very good advantage. If you have plus Java experience, it's more advantage. You will get a lot of calls. If you know Spark and Hadoop well, you can crack job in a week because we have openings. Okay. Yep. So we saw that syntax. Next, we can also use uh, filter operations. Filter operations. So filter is from data frame, right? Data frame. Sorry, filter function is from RDD, right? RDD. Yes or no? So we can use data frame dot filter. X implies x of 1 dot to string starts with D. So x of 1 means, so this one, x of 1 means D, this one, name. In this we are checking start with D. Whose name start with D? Display all the employee names. Okay. This syntax we are writing. So let's export this one. Then df3 dot show, we got employee's name whose name start with D, right? Simple select query, right? Simple select query. We didn't write select query. We used RDD kind of syntax. Yes or no? On top of data frames, we are using RDD syntax. So you can use DSL and we can use RDD syntax on data frame. RDD kind of syntax. Next condition, what I am doing. So df2 dot with column doctor. So I am adding column. I am adding column with column. New column I am adding doctor. So literal by default for doctor column, what I am storing? Empty value. Empty value. Then for that column, I am creating one more age group. I am creating one more column called age group. And I am writing condition. Age group, column name is age group. When call dot age, I am writing condition. Call dot age greater than 50, group 1, otherwise group 2. So in that column, we are assigning group type. But here we are assigning doctor equal to null. So you got the point, right? Let's execute this one. Okay. df4 dot show of 5 records. So doctor column is empty, right? Next I am calculating one more column. What is that column? Age group column. But age group column we are assigning some value. Based on condition we are assigning some value. Let's execute this one. Let's execute that show. So age column it is giving group 1 and group 2, right? Based on age we are creating age group. Yes or no? Okay. Next, we are creating one more column, survival. When survival equal to yes, when survivor equal to yes, I'm changing true, otherwise false. Means I'm doing some transformation. Instead of yes and no, what we are doing, survival equal to yes, then I'm changing equal to true. Okay. So I'm converting ID column to float. If you want to change float, gender column to sex, we are changing column names. For that one, we are using with column and with column renamed. With column renamed is used to change column name. With column is used to add column or calculate value and store into that new column, right? So I'm stopping now because some people are missed today. Is that fine? Okay. So okay, I'm stopping now. If you have any queries, please ask me. We'll discuss that queries now.